So I'm JLevCwac, and my partner is Christian Wachter.
That's me.
Here's our statically indeterminate problem. So what we have is two bars in between two fixed walls, and then bar 1 is going to be removed and thermally expanded, and then reinserted and reattached between bar 2 and the wall. So this will apply a strain to both bars. And our goal is to find delta 1 in terms of delta t, and our givens are alpha 1, L1, L2, and then the flexibilities for both bars. So for our force balance, after the bar is reinserted, there will be two forces, reaction A, reaction B, and these forces are equal and opposite. So our force displacement then, delta T for the initial thermal expansion is equal to alpha delta T times L1. Then delta 2 will be F2 times RA, so that will be for this bar here. And delta 1 is going to be F1 times RB, that will be for this bar here. For our compatibility equation, delta T plus delta 1 plus delta 2 is all going to be equal to 0. It's because the walls are fixed, so the distance in between them won't change. So all the changes in the length of the bars has to stay under that fixed limit. So for our solution here, we'll start with the force balance, RA equal to RB. Then we'll do some algebra here, move the F's over to the other side of the equation, then set them equal to each other and solve for delta 2. That gives us F2 over F1 times delta 1. Plugging that then into the compatibility equation, we end up with delta T plus this plus delta 1. Moving over here, we'll factor out delta 1 and move delta T to the other side, and then divide by this quantity here, resulting in an equation for delta 1. And then going back to the original force displacement for delta T, we plug this into this equation here and end up with our final answer, delta 1 in terms of delta T. This makes sense because if delta T is negative or the bar is cooled, then bar 1 will shrink, and so both bars will need to stretch in order to fit between the walls again. So a negative value here times a negative value here will be a positive quantity there, and that would mean that delta 1 here would be positive to stretch the two bars out to fit between the walls. And the same thing if delta T were positive, this would all remain negative, and both bars would have to be compressed to fit between the wall, and so delta 1 would be negative in that case. So that is our statically indeterminate problem.
Power.